Good morning, and thanks for the organizing committee of the Second International Conference on Modern Medicine and Global Health for inviting me today to join as a keynote speaker. So I'm honored today to address you on a critical issue that affects all of us related to the assessment of disinfection of pathogenic microorganism in water supply system. So our water sources are essential to life, and ensuring their purity is very important. Without further delay, please let me share with you my presentation. Yeah. So I have selected the title of Safeguarding Water Quality, Evaluating and Mitigation Pathogenic or Microorganism in Water Supply Network. I think this title is very important as we have a lot of people suffering due to the lack of pure treated water, healthy water, and that's why we need to look into the causes of a lot of diseases and how to solve it based on the current practice and future opportunities. Um, This is a short biography about me. So this is Prof. Bashir from University Tunku Rahman, and I'm specialized more in environmental technology, environmental engineer, particularly in the topic related to water treatment, water quality, and recently listed as one of the top 2% researcher in the world according to Stanford ranking in the field of environmental technology. So this is to share with you about my University Tunku Rahman, Utah, Malaysia in Kambar. So hope that you can visit Kambar and you are welcome to meet me there and to initiate collaboration with the university. In my talks, I will focus on a few topics, including short introduction, environmental importance of water quality, the source of pathogenic and pollutant and pathway, their health impact. Then we'll focus more also on the treatment challenges and treatment opportunities as well. Um, so basically, I think everyone know how important is the water in our life, whereby 70% or more of our body consists of water, and for baby is close to 90%. So that's why it's water quality is very important, particularly when we talk about biological contaminant or microbiological contaminant. So definitely water use for drinking, agriculture, industrial use, domestic use, and transportation, recreational, and hydropower. So it's many uses. But for us here, we will focus more on the water usage for human and environment. So basically, water requires several type or water contains several type of impurities or contaminants which pass from its origin, place of consumption due to set level, suspended or colloidal or dissolved solid. So basically, we have different kind of contaminants. Could be organic, could be inorganic, could be toxic, could be non-toxic, could be physical or chemical or biological, right? So different in nature are those kind of impurities. And some of the impurities, when for certain level like calcium, magnesium, or iron, it could be healthy, but when it exceeds certain limit, will be non-healthy. And coming to this figure, show the type of pollutant that we might have, including physical, chemical, and biological pollutants. So for physical, those can be seen or can be removed easily by flotation, uh, sedimentation, or etc., including gases, liquid, and solid. What we talk about chemical, we talk about organic or inorganic pollutant that's normally dissolved within the water soluble. And then we also talk about the critical part that I'm addressing today, which is the biological pollutants or impurities. And this is mainly include this pathogenic bacteria or fungi and so on that can cause harmful effect on our health. Basically, the contamination of water is, I mean, the type of pollutant in water is quite wide, not limited to to the one we know now. There is many new emerging type of contaminant, including pharmaceutical, care product, uh, PFAS, microplastics, pesticides, herbicides. All of those new contaminants also create a challenge where our water treatment system is not ready yet to deal with them, because we don't know the impact of the current treatment practice on those kind of pollutants. But basically, my focus today will be on this biological parameter, especially the pathogen and pathogen indicator. We know the pathogen is those kind of things that can cause harm to the human health and so on. However, pathogen indicator is something like countable kind of bacteria that we use as indicator on the presence of the pathogen. So the pathogen indicator normally are not harmful in themselves and they are countable, environmentally friendly. But we use that one to see them to be an indicator about the pathogen, about the exist of the pathogen. So when we talk about pathogens, we talk about bacteria, viruses, fungi, protozoa. Those cause diseases, taste, odor, and in some cases will cause pipe corrosion and pipe blockage. We have different kind of those elements from those elements. For example, the bacteria in the water, we might have the typhoid, cholera, jaundice, and then viruses, we have hepatitis, flu, polio in Africa, and we have protozoa, we have fungi, so different kind of pathogens and so on. Coming to the importance of water quality. Looking to the kind of pollutant that might be present in the water, we talk about many, including those biological or parameters and pathogens. That's why it is very important to use the clean water that is free of the sources of those sources related to pathogens or contaminants. Why? Mainly because of the water is a source for drinking. So we need to have healthy or clean water for to protect public health. And also, clean water needs to be used for food and agriculture because at the end, the product harvested will be used to feed the people. And then also for socio-economic development, because we talk about freshwater ecosystem, we talk about recreational attraction, tourism, right, sustainability issue. So if we talk about in general the importance of water quality, actually it can be divided into many categories, including urban and domestic use, because increased water treatment and inspection cost, maintenance cost for sourcing and of this one will be important, as the increase of wastewater treatment will cause more cost to treat it and to go for more regulation to control that one. And another part is the human health. As we mentioned, polluted water is the world's largest health risk and continue to treat or to cause risk on the quality of life of the people. So associated with this, health service cost will be increased, expectation will be reduced, and many other related issues will appear. Also, it have ecosystem health where not, dirty water or polluted water will damage the ecosystem and the environment and will influence on the biodiversity as well. Also, talk about industrial productivity where exclusion of contamination of water for industrial use result in increasing water scarcity, scouring of infrastructure, and clean up costs for spills, and accidents. Also, it will have impact on the social value and tourism, where tourism looking for swimming, fishing, seafood. So clean water is an issue here. Same for agricultural productivity, where contaminant uh, water might have bad effect on the plantation growth, soil productivity, fertility, and other factors. Same for the commercial of fisheries and properties value that can be influenced by the water equality surrounding that one. Moving to the source of the pollutant, basically we have so many sources of pollutant now, from point source of pollution and non-point point source of pollution, including this domestic waste, human waste, animal waste, pesticide or agriculture activity, and farming activity, and market activity, and etc. Definitely, some of them source, some of them non-source polluted. So if you can see here, the human use coming from toilet, and then we go for the disposal. It might go to the wastewater treatment plant, might go to the landfill waste. But at the end, the wastewater treatment plant will have a limited treatment process, and then the final discharge will go to the river or to the sea, whatever. And then the landfill also sometimes not fully protected, so leachate can percolate and come to the groundwater with all of the pathogenic and polluted wastewater back to the environment. Even the treatment system, as I mentioned, is limited. It will not go for full 100% treatment. And then all of this one will come back to the water sources, water bodies, either river or groundwater, and then coming back to the farming, agricultural activity, then coming back to the human. So meaning that what we produce here is coming back to us, which cause more risk. So the pathogens here should be clarified that is not only related to the human waste here and animal waste, farming, agriculture, but also hospital discharge as well. And that's why here we talk about waterborne diseases here, the effect including cholera, dysentery, jaundice, jaundice, and then we have hepatitis, typhoid. So we have so many diseases, or we call it waterborne diseases, can be presented in the water, right? So for example, this is cholera present in water contaminated with the human waste. And if we talk about dysentery, we talk about physical contamination of water or food. And then we talk we talk about obstruction of liver. And then in terms of hepatitis, we talk about it's caused by viruses. For example, hepatitis A and E, which spread through polluted water. And then we talk about typhoid, we talk about it spread by polluted water containing bacteria such as Salmonella. In terms of treatment now, you need to know that most of the water now is treated by this kind of process. We make some aeration, and then something like we call it flocculation, followed by sedimentation. And so this is to allow the particles to settle down, followed by filtration process. This is the coagulant we use, and then at the end, the process will follow sedimentation. And finally, for the water treatment, we are talking about before usage by the customer, it will go through chlorination, which is disinfection. This is basically the function here is to kill the bacteria, right? So this is basically the process, and then backwash for untreated water or remaining water. And the clean water definitely can go to the consumers. Right? Definitely the solid particle here can come as sludge and can be. Okay. But so this is the process here from the real wastewater treatment. We have aeration process for the gases and stabilization. So we have here coagulation process for mixture, and then we have flocculation, filtration before final sent to the domestic. However, now due to the high pollution in the river in Malaysia and many other countries around the world, This basic treatment system or conventional treatment system of water uh, is not sufficient where the pollution level is high. That's why we need more complicated and comprehensive process. That's why now we use pre-ozonation or pre-chlorination for killing the bacteria at the early stage of the treatment, because the amount of bacteria will be high and we will need to reduce them or to eliminate them before the process of treatment start, whereby most of the bacteria when die here, it will go through coagulation process, then will go sedimentation at this stage, so can settle down with the sludge. Yet, the remaining amount of pathogens, we can reduce them by going for post-chlorination, the final stage before discharge. So in this advanced treatment system, we will have two a level of or two stages of disinfection. One before the treatment start to reduce or to eliminate the bacteria or the pathogens, and the final one, the final disinfection, to make sure that there is no more bacteria in the process, and then to additional amount for the what you call to the supply system for the piping through the transportation or transformation of the waste to the water to the public. All right, so this is the post treatment here, or the post chlorination that can be used. Okay, so basically, if we talk about the general process, as I mentioned, general process disinfection will be final stage before we go for the water distribution. However, for the advanced system, this is conventional system. For the advanced system, we will have two stages. One stage here before start the treatment, and then the bacteria will go with the sludge here, and another one will be final stage here. There is basic criteria basically to select of disinfectant, including any disinfectant used, either chlorine, ozone, or UV, or silver, whatever nanomaterial used. We must select them based on their characteristics. So good disinfectant must be effective, killer, work under normal environment conditions, end product residual should be non-toxic, low cost, proper residual should be provided, easy, safe to store, transport, and also easy in analysis of the dosage residual. Treated water should be non-corrosive as well. So we have to control the residual. So basically, here quickly I will go through different type of disinfectant, including, as you can see here, chlorination, boiling, treatment with excess lime, and then treatment with ozone, iodine, potassium permanganate, ultraviolet ray, and treatment with silver. This is actually the gas chlorination, the most common and effective uh, process used for disinfection. However, we need to highlight that this process also has some disadvantage. Basically, the transportation of the chlorine gas is critical and demanding, and needs skilled worker to deal with this process, because chlorine gas is explosive and corrosive. And here you can see that for chlorine, actually, you need basically small dosage actually to for 30 minutes to kill those kind of viruses, bacteria, and etc. Same for ozone. Ozone actually considered powerful oxidant and is very suitable when we use with the conjunction with secondary disinfection such as chloride or chloramine. We have also this kind of the mechanism, if I would say, the mechanism of killing the microorganism is that the chlorine or those disinfectants will destruct the cellular structure organization and will make interference with energy yielding metabolism, and then interference with the bio-yielding biosynthesis and the growth. And combination of those mechanisms can be responsible for disinfection depending on the type of the microorganism. Also, as we mentioned, we have the ozonation process can be used, producing the ozone oxygen under certain circumstances. Definitely, one of the process also which common is ultraviolet radiation using the sunlight is considered important. And then similarly, the silver, which is also found to be used for disinfection. Potassium permanganate is used also in rural area where we cannot find the energy supply, and the process will be need to be easier. Yet there is a few problems related to chlorination process, including the byproduct formation, including the trihalomethane, THM, which is highly carcinogenic. And this is occurred due to the reaction between the methane and the chloride or chloride and other material. So this is proven to be a cancer causing, and especially in the blood. So normally those trihalomethane caused due to the initial amount of concentration of chlorine might be high, and there is a different type of organic concentration at different level. There might be some reaction between them due to certain pH level, certain circumstances like the presence of bromide, the reaction time, then it might be there. That's why that the chlorine concentration have to be tested before, and the organic should be treated before we go for the disinfection process. Talking about the recent innovation and challenges, now there is a lot of innovation, particularly in the area of nanomaterial, and nanotechnology now can contribute to the disinfection process. Basically, Hong in 2021 utilized advanced oxidation process like ozone, UV, and hydrogen peroxide photocatalyst for effective disinfection. Another research investigated the electrochlorination process for effective disinfection. Why electrochlorination? Because the chlorine will be safe, but is not in the gas process, so transportation will be easier. So when we do the electro process, then this is kind of produce the chlorine that we use for the disinfection. So this is like a side generation of disinfectant, and this is well save the storage and the transportation part. Another study that conducted by Wang 2019 in the title of Nanotechnology in Water Treatment Application and Emerging Opportunity found that nanoparticles shows a high surface area facilitating increased contact with waterborne pathogens and enhancing the overall disinfectant efficiency. And the unique properties of nanoparticles enable targeting action against a specific contaminant, minimizing the impact on beneficial microorganisms. Coming to challenges, actually, there is few challenges, mainly the byproduct. Normally, when we have this chlorine gas or other disinfectant, we might have some byproduct that we need to investigate further their health impact and how to eliminate. The second part related to the residual of disinfectant, particularly the chlorine, when we see the balance between how much we need from chlorine or disinfectant to avoid the high residual of disinfectant in the water supply. And another one which is related to emerging contaminant. Now we know there is a lot of emerging contaminant related also to hormone, antibiotic materials, and this might present different kind of pathogens and bacteria that mean further investigation related to this emerging contaminant and pathogen that may be resistant to conventional disinfectant method might need to be addressed, and further research can be done on that one. As a conclusion, disinfection, the defense against waterborne pathogens demand innovative approach. Traditional methods have paved the way, but we stand at the face of transformative technology. Nanotechnology now can take a lead in that pace to have more sustainable, environmental friendly disinfectant. Also, our collective responsibility is to strengthen the resilience of the water supply system by embracing cutting-edge assessment of disinfection methodology. We not only protect public health, but also safeguard our most valuable resources for generations to come. As we navigate the complicated issue of water quality, collaboration between researcher, policymaker, and industrial leaders become essential, become the cornerstone of success. So together we can shape a future where clean and safe water is a universal right. Thank you very much for attending this wonderful conference. I hope that you will enjoy the different session will be conducted under this conference, and we can have more discussion about the content and the related topic. Thank you very much. I appreciate your attendance. Thank you.